Welcome. This is a video based upon percentage change in financial applications for IBDP AISL. So the first question we are going to do that is the population of the village increases by 8% every year. If the population today is 1000, find the population after 5 years. So we are going to use the formula. So future value equals to 1000 times 1 plus 8 upon 100 whole to the power of n, which is 1000 times 1.08 whole to the power of n. In case of the first part, it is 1000 times 1.08 whole to the power of 5, which is going to be 1469. Coming to the second part, it is 5 years ago. So 1000 times 1.08 whole to the power of negative 5, which is 681. Now, in the third part, find the number of full years after the population will exceed 2000. So, what am I going to do that? 1000 times 1.08 whole to the power of n equals to 2000. Use the GDC to calculate the value of n as 9.0064. So that n equals to 10. Now part B. So this is all about part A. Now coming to part B. First part. Now if it is decreases by 8%, in that case the formula for final value will be 1000 times 1 minus 8 upon 100 whole to the power of n. So first part it is after 5 years. So it is 1000 times 0.92 whole to the power of 5, which is going to be 659. In the second part, 5 years ago, so 1000 times 0.92 whole to the power of negative 5, which is 1517. And in the third part, number of full years will fall under 500. So 1000 times 0.92 whole to the power of n equals to 500. Use the calculator, you should be getting it at 8.31. So therefore, n equals to 9. Coming to the second question. Now that one was with GDC. What is this? Use the basic calculator. Now we can do it on with GDC also. Rather, I will be doing the same question with GDC, the first question. How am I going to do that? So let me write there. If we want to do by GDC. So for that, I percent will be equals to 8 and PV should be equals to minus 1000. Then PMT should be equals to 0 and P upon Y should be equals to 1. C upon Y should be equals to 1. Then what it says, set n equals to 5. You should be getting it at final value as 61469. If you set n value as negative 5, you will be getting the final value as 681. Then in part 3, set the final value as 2000 and get the value of n, which you will be giving it as 9.0064. So therefore n equals to 10. But for part B, I should be equals to minus 8% because it is decreasing. So minus 8. Principal value will be minus 1000. Then set PMT to 0. P upon Y should be equals to 1. C upon Y should be equals to 1. Now set n equals to 5. You will be getting final value as 659. Then n equals to negative 5. Final value as 1517. And final value as 500. Then you will be getting n value as 8.31, which is n equals to 9. Coming to question number 2, the population of the city at the end of 1972 was 250,000. The population increases by 1.3%. Write down the population at the end of 1973. So you do the by calculator, you should be getting it at 253250. Find the population at the end of 2002. So 1972 till 2002. So it is going to be nothing but how much? 30 years. 30 years, and it is increasing by what? 1.3%. So it is 1.013. So then you should be able to get that answer as, if final value, use the calculator, you should be getting it out 368,000. How long will it take for the size of the population to exceed 40,000? So 250,000 times 1.013 whole to the power of n is greater than 400,000. So use the GDC to get the value of n, which should be equals to n is greater than 36.4. Use a point of intersection. By drawing the graph, you should be able to get the value of n as 36.4. N is greater than 36.4. Sketch the graph of population in terms of t after 1972. Show that the information in question number part B and C. So what is that? At initially the population is 250,000. At 0 it was 250,000. So somewhere over here. Then part B in 2002 it means after 30 years it is 368,000. After 30 years it is 368,000. So it is approximately equals to 400,000, and at 36.4 it becomes 400,000. So it keeps on increasing in this way. Exponential growth. Question number 3. The population of a bacteria is growing at a rate of 2.3% per minute. How long will it take for the size of the population to double? So 2.3% means 1.023. Then if at all the population is A, it should become, after how many years T, it should become 2A. The population is A initial value, it should become 2A. Then AA gets cancels. So what is the equation I get? 1.023 whole to the power of P should be equals to 2. If you want to do by GDC, you can directly get the point of intersection, which is equals to 30. Or else if at all you want to do by ln, so ln 1.023 whole to the power of P equals to ln 2. So T ln 1.023 equals to ln 2. So T equals to ln 2 divided by ln 1.023. So which is going to be 30. Now the graph you can use by GDC to get the graph for the same thing. Now question number 4. Each year for the past 5 years, the population of a certain country has increased at a steady rate of 2.7%. The present population is 15.2 million. What is our population 1 year ago? So 1 year ago, just divide by 15.2 divided by, or else 15.2 times 1.027 whole to the power of negative 1. Simplify that, 14.8 million. Then part B, what was the population 5 years ago? So 15.2 times 1.027 whole to the power of negative 5. It is 13.3 million. Graph, again you can use the GDC to get the graph. Question number 5. An amount of 10,000 is invested at an annual interest of 12%. Find the value of this one after 5 years. So either you can, so first method is use FV. So by the formula, so 10,000 times 1 plus 12 upon 100 whole to the power of 5, which is 17,623.42. Then part 2, if the interest rate is compounded half yearly. If at all it is compounded half yearly, then it is going to be 10,000 times 1 plus 12 upon 100 times 2, because in a year there are 2 half years, and 5 also times 2. So it's going to be 17,908.48. Now if it is compounded quarterly, in that case it will be 10,000 times 1 plus 12 upon 100 times 4. 5 is also multiplied by 4. So it becomes 18,061.11. Then part 4, if it is compounded monthly, so it is 10,000 times 1 plus 12 upon 100 times 12 whole to the power of 5 times 12. So which is 18,166.97. Then the value of the investment will exceed 20,000 after n full years. Find the minimum value of n if it is compounded yearly and compounded annually, monthly. So for part B, part 1, 20,000 equals to 10,000 times 1 plus 12 upon 100 whole to the power of n. use GDC to get the value of solution as n equals to 6.11. So n equals to 7. Next, part 2, if it is compounded monthly. So 20,000 equals to 10,000